Welcome to today's deep dive. We are looking at a stack of spec sheets and AV engineering manuals today to, well, decode a bit of a puzzle for you.
Yeah, pretty expensive puzzle, actually.
Right, exactly. We are talking about a $2,000 piece of hardware. It is called the Atlona AT-HDR-H2H-44MA. It's a 4x4 matrix switcher.
Rolls right off the tongue, doesn't it?
Oh, totally. But okay, let's unpack this because usually when you look at a little metal box that just connects a few HDMI cables together, you expect it to cost maybe 50 bucks. Why does this one cost 2 grand?
Well, it's because we aren't just switching simple video signals anymore.
Yeah.
The mission today is to look past that physical box and understand this invisible 18 gigabit per second data traffic jam happening in modern 4K systems.
Okay, yeah, let's talk about that traffic jam. The specs say this is a 4x4 matrix, meaning it takes 4 different HDMI inputs, like a streaming box or a Blu-ray player or a PC, and routes them to 4 different screens simultaneously.
Right, like an ultra-efficient traffic cop directing high-speed data.
Exactly. But then the manuals throw around these terms like 4 chroma sampling at 60 hertz. And I know that sounds impressive on a spec sheet, but what does that actually mean for the data?
Basically, it means the device is handling the absolute maximum amount of color data possible without compression. In a standard video stream, your TV actually just, guesses some of the color data to save bandwidth.
Oh, wow. So it's filling in the blanks.
Yeah, exactly. But with 4 sampling, every single pixel gets its own dedicated color information 60 times a second. That requires a massive data pipeline.
Right. And if the switcher can't process that instantly, I'm guessing your video stutters or drops out entirely.
Exactly. But raw speed isn't enough anymore. It also has to manage communication between the devices. What's fascinating here is how it manages the EID.
Right. The extended display identification data. I was reading about that in the sources.
Yeah. Think of EDID like a translator at the UN.
Okay. I like that. How so?
Well, imagine your 4K Blu-ray player is blasting out a high-end HDR10 signal, but you are, routing that video to an older 1080p TV in the kitchen.
Without a translator, that kitchen screen just goes black, right?
Yeah, exactly. The Atlona steps in, reads the specific capabilities of that kitchen TV, and instantly tells the Blu-ray player to send a format that TV can actually understand. It forces a digital handshake.
Okay, here's where I have to push back a bit, though. Because the specs also brag about HDCP 2.2 compliance. And isn't HDCP just that frustrating copyright blocker?
Well, if we connect this to the bigger picture, it's actually...
Because every time I try to plug my laptop into a conference room monitor, HDCP gives me a blank screen. It thinks I'm trying to pirate a spreadsheet or something.
Right, yeah. But that is the exact headache this device is engineered to eliminate. It features active HDCP management.
Wait, really? How does it manage that without breaking the rules? Does it just ignore the copyright?
No, it acts as a smart gatekeeper. When you plug in that laptop, the switcher detects that your presentation isn't protected movie content.
Okay, so it knows what you're sending.
Right. It actively tells the laptop, hey, I'm not an HDCP device, just send the raw video. So your presentation passes through flawlessly.
Oh, that makes sense.
But if you switch to a protected movie, it immediately reinstates the encryption to keep the content secure. It intelligently knows the difference.
It's actively negotiating the connection based on the content. That is smart. Now, the video is sorted, but if this box is hidden away in a basement server rack somewhere, what happens to the audio?
So it splits it perfectly in sync. It physically separates or de-embeds the standard 2-channel audio from the HDMI signal. Then it sends it out to your whole house analog speaker system.
So the kitchen speakers get the basic stereo mix, but doesn't that ruin the sound for the main theater?
Not at all. Because simultaneously, it leaves the massive, uncompressed surround sound formats like Dolby Atmos or DTS:X embedded in the HDMI cable going straight to your main living room receiver.
Got it. But this raises a practical problem. If the box is in a rack in the basement, how do I actually turn on the TV in the living room? I mean, I don't want to juggle 4 different remotes.
No, definitely not. That's where CEC and RS-232 control come in. CEC allows commands to travel directly over the HDMI cable itself.
Right, kind of like a magic wand that can turn specific displays on or off remotely.
Exactly. And the IP control lets you integrate the switcher into a smart home network.
Right.
So when you hit Watch Movie on your phone, the switcher automatically sends a signal down the cable to turn on the specific display and switch to the correct input.
So what does this all mean for you, the listener? Ultimately, a device like this isn't just a switch. It's an invisible experience manager.
Yeah, it handles the translation, the copyright handshakes, and the audio routing, so you just see a picture on a screen.
Exactly. If you've ever battled a tangle of HDMI cables or, spent 20 sweating minutes trying to fix an unsupported format error before a presentation, this is the technology working tirelessly behind the scenes to eliminate that friction.
It really is designed to just make sure it all works seamlessly.
It makes sure it just works. But it leaves me wondering, as our homes and offices demand even higher data rates for 8K video and beyond, will physical matrix switchers like this remain the gold standard?
That's a huge question right now in the industry.
Right, like will we eventually see these massive AV data streams move entirely over our wireless networks, making the physical metal box completely obsolete?
It's definitely something to keep an eye on as bandwidth improves.
Absolutely. Well, it's something for you to think about next time you plug in a cable.